Welcome to the ninth part of VCAA Specialist Math 2022 exam papers. In this video, we will present exam paper 2, section B, question 2, which consists of 4 parts. In a show that question, students are required to clearly and logically show the steps that lead to the given result. In part A, section 1, some students use the CAS to solve the given equation and then substitute back their answers. In part A, section 2, most students give at least one correct answer. In part B, some students use the Cartesian values to plot the approximate position of the points rather than the more effective approach of considering the polar form, which resulted in accurate positions. A common incorrect argument in part C was theta equals negative pi over 12. Many students did not draw a ray. In part D, most students who correctly applied the segment area formula were successful. A smaller portion correctly used a definite interval, but this approach usually led to error. However, some students who used the area formula, either of segments or triangles, had difficulty. Welcome to this VCAA Specialist Math exam paper series. This is section B of 2022 exam 2 paper. There are total 6 extended response questions in section B. In this video, we will present the second extended response question. There are 2 complex numbers, u and v, in question 2. u equals a plus I and v equals b minus square root 2i, where both a and b are real. There are 4 parts in this question, and part A has 2 sections. The question in section 1 of part A is to show that a squared plus 1 minus square root 3, or in parentheses times a minus square root 3 equals 0, given that u times v equals square root 2 plus square root 6 and plus square root 2 minus square root 6, or in parentheses I. In section 2 of part A, it says that one set of possible values for a and b is a equals square root 3 and b equals square root 2. The question in this section is to find the other set of possible values of a and b. Part B of this question is to plot and label the points representing u equals square root 3 plus I and v equals square root 2 minus square root 2i on the Argand diagram as shown here. Part C of this question states that the ray given by argument of z equals theta, which passes through the midpoint of the line interval that joins points u equals square root 3 plus I and the v equals square root 2 minus square root 2i. The question is to find the value of theta and plot this ray on the Argand diagram as shown in part B. In part A, the line interval joins the points u equals square root 3 plus I and the v equals square root 2 minus square root I, cuts the circle modulus of z equals 2 into a major and a minor segments. The question in part D is to find the area of the minor segment. Since u equals a plus I and v equals b minus square root 2i, and u times v equals square root 2 plus square root 6, and plus square root 2 minus square root 6, all in parentheses I, u times v equals a plus I, or in parentheses, times b minus square root 2i, or in parentheses, which equals a times b plus square root 2, then plus b minus square root 2a, or in parentheses I. After being equated to square root 2 plus square root 6, then plus square root 2 minus square root 6, or in parentheses I, two simultaneous equations are established to find the values of a and b. So we have a times b plus square root 2 equals square root 2 plus square root 6, and b minus square root 2, a equals square root 2 minus square root 6. That gives b equals square root 6 over a. After substituting square root 6 over a for b, we have square root 6 over a minus square root 2 times a equals square root 2 minus square root 6. After rearranging and simplifying the equation, we have a quadratic equation a squared plus 1 minus square root 3, or in parentheses times a minus square root 3 equals 0, as required in section 1 of part A. Since a squared plus 1 minus square root 3, or in parentheses times a minus square root 3 equals 0, its discriminant delta equals square root of 1 minus square root 3, or in parentheses squared, minus 4 times negative square root 3, which equals 1 plus square root 3. Hence, a1 equals square root 3, b1 equals square root 2, and a2 equals negative 1, b2 equals negative square root 6. In part B, both complex numbers u and v are converted from rectangular form to polar form. Here u equals square root 3 plus I, which is written to 2 times 6 of pi over 6. Accordingly, v equals square root 2 minus square root 2i, which can be written to 2 times 6 of negative pi over 4. After being converted to their corresponding polar form, they are plotted in the diagram at below. As for part C of this question, since the ray OM passes through the midpoint of the line joins U and V, the triangle OUV is an isosceles triangle, and the line OM bisects the angle UOV as shown in the diagram. Then the angle theta equals argument of U plus argument of V all over 2, which equals 1 over 2 times pi over 6 minus pi over 4, or in parentheses, which equals negative pi over 24. However, an alternative approach to part C is to find the complex number at n, which equals u plus v, or in parentheses, over 2, which equals square root 3 plus square root 2 all over 2, plus 1 minus square root 2 all in parentheses I over 2. Hence, theta equals arctangent of 1 minus square root 2 all over the sum of square root 3 plus square root 2, which equals negative pi over 24. As it can be seen from the diagram, the line UV cuts the circle into a major and a minor segment. Part D of this question is to find the area of the minor segment. Here we assume alpha represents the angle UOV, which equals pi over 6 minus negative pi over 4, which equals 5 pi over 12. Hence, the area of the minor segment can be expressed to 1 over 2 times alpha times 2 squared minus 1 over 2 times 2 squared times sine alpha, which equals 5 pi over 6 minus 2 times sine of 5 pi over 12, which approximately equals 0.69 units squared.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.